Hello scholars, welcome back. So we're going to be going over activity 3.3, calculating percent error. We are on page 231. It says, airline travel has come a long way since the days of Orville and Wilbur Wright. In 2015, there were approximately 9.1 million flights that took off from U.S. airports, carrying approximately 895.5 million passengers. To transport this many passengers to and from their destinations, airlines have to make good estimations about the number of flights passengers will book, the size of the airplanes to use for a given route, and the approximate arrival time for each flight. Tracking the accuracy of these estimations is important for airlines. Calculating percent error is one way to compare an estimate value to an actual value. To compute percent error, determine the difference between estimated and actual values. Remember, difference means subtraction, okay? So to compute percent error, determine the difference between the estimated and the actual values, and then divide by the actual value. This is the equation. Oops, yeah, here we go. Now, I have a question. Why do they use subtraction and division in this equation? Why do you think? And then, when using this formula, when would the answer be a positive and when would it be a negative? What would happen in the formula to cause a positive answer or a negative answer? And then, if your percent error, if your estimation was higher than what actually occurred, would your percent error be a positive or negative? And then if your estimate was lower than what actually occurred, would you have a positive, or would your percent error be a positive or negative? I want you to think about these questions as we're going through. Now I'd like you to direct your attention to number 4. It's on page 232. It talks about Bernice and how she calculated percent error for a flight that went from DC to Boston. She was first told that the flight took 10 minutes longer than the estimated time. Okay, so the actual was 10 minutes longer than the estimation. And she calculated that the percent error was 10.3%. But later, she found out that the actual flight time was not 10 minutes longer than the estimate. The actual flight time was 10 minutes less than the estimate. Okay? So the actual flight time, I want you to I'd like to remind you that the percent error equals actual value minus estimated value all over the actual value. So our actual value changed. So not only does the sign in the numerator change, but the denominator's value changed. So the value of the percent error is going to change because the denominator is different, okay? So I want you guys to remember that as you're doing this problem, okay? If you guys have any questions about any of these problems, please message me on Google Classroom, email me, or come to tutoring. I'd be happy to help you out, okay? I'll talk to y'all later. Have a great weekend.